Okay, so now let me explain to you how this particular post condition will be checked at the runtime. That'll be very important to see. See here. So let's say again we are considering as the push gym, and we already got this particular stack, and we talk about strategy number 2. Okay, strategy number 2. So that means the top of the stack correspond to the front of the list. Let's say, okay, and then let's assume that we also got our conversion function, which will be related to exercise number 2 that you're going to do, right? That's something you will do, assuming that you have done that already. I'll just tell you the final outcome, okay? So now, this is the pre-states, right? This is a pre-states. This is a pre-states, it's before the push, and we got exactly 3 elements. And then we're going to see that in order to check how is this particular post condition for the push going to be checked, is very important to see, okay? So now in the pre-state and the post-states, in order to, let's assume that there's no precondition for the push, so nothing to be checked, right? So now, right before we execute the implementation, we're going to see what are the old expressions that we need to memorize or cached in the pre-state, right? We learned about this in the previous week lecture. So this is the only old keyword we have. So this is what we have to cache over here. Model.deep twin. First of all, what is model? And then we're going to take a deep twin of that, right? So model.deep twin is simply just going to create a separate object, right? So now what you will do is it's going to call model for the very first time in the pre-states. So in the pre-state, we're going to basically just duplicate all the string object over here, Tom, Alan, and Mark, right? They will be string separate objects. So any aliasing is going to be not present. So so in the pre-state, we're just going to say model over here is simply going to point to just a sequence over here, right, of size 3. And then, even though this is really in this particular order, however, from the user's point of view, always the top of the stack will be the last element of the sequence. So this will be the top, right? That's a public view that we talked about previously. So now in this case, it will be Tom, and also Mark, and also Alan, right? How you actually convert this one here into this particular model here, again, it is exercise number 2 that you have to do, right? Make sure you do it. So now this is the old model that we have. Let me just highlight it. So this is what we got, right? So this is what we got, okay? And when we say deep twin, so here I simply, the way I draw the deep twin is Alan, Mark, and Tom over here. Alan, Mark, and Tom, they're simply separate objects from Alan, Mark, and Tom. So that's like a deep twin. Okay, that's what I meant. And then, what about after the push? So after the push, what's going to happen is, so we're simply going to, for the linked list side, right? The top is going to change. So top is not going to be here anymore. What's going to happen is, you're going to have a new node for the linked list. And then we're inserting gym, right, to the front of the linked list. So this will be gym. You can think about gym is now going to link to over here, the old top, and now the top will be over here. So this is the top of the stack. So that's the post-states implementation, right? So still the same linked list. But now we're going to call model the second time. So you can think about this is the call. You can think about this as second call. Second call, which is in the post-states. And the previous one that we talked about over here, this is the first call, which is in the pre-states. Okay, so now how do we, for the second call, we're going to basically call the abstraction function again. So that the way we do it is, we're going to simply, the model is actually going to be like this. It's going to point to this particular sequence over here of 4 elements, and then the way we create it is going to be, again, exercise number 2 you're going to do, right? But from the public view, always the last element in the sequence should be the top over here, right? So now what's the new top? What will be gym, right? All others, from the client's point of view, all others should remain the same. So there should be Alan, Mark, and also Tom. Is it okay? So far so good. So we got this model over here, so that will be the post states. So now we got a pink over here, and also we got a green. So now how do we compare these two? The way we compare them is as follows. We are saying that the pink over here is equivalent to, so this is the tilde is equal query that's already predefined, also already predefined in the sequence class. You're just going to compare two sequences, one element by one element. At the moment, you can see this sequence here, the model in the post states, and also the model here in the pre-state. They are different, but they are similar. You can see it's exactly this new push element that makes the difference. So the way we do it is by doing this. We're saying that the old model you have dot appended. The appended is the query that I spoke about. Whenever you want to use a math model to write contracts, you have to use the queries to help you. Okay, appended, again, you can look up the definition of appended in the Eiffel Studio for a sequence. I'll let you do it. But the appended over here, rather than just appending directly to this model here, in that case, that will be a command. So what we want to do is we want to return a new sequence. So you can think about what that's going to do is, over here, you can see it's the old model.deeptwin.appended. So that means for this particular sequence here, we're just going to create another version, right? Just under the hood. You can think about model, the pre-state version.appended G. And then the G over here is whatever element we are pushing, which is in this case Jim, right? So now this is actually going to create just another sequence over here. And conceptually, you can think about this sequence over here is going to be Alan, Mark, and Tom, but with G, in this case Jim, appended to the end. In this case, that would be Jim. So think about this guy over here. Let me use blue over here. Think about this entire expression over here. This entire expression is exactly this blue thing, this blue sequence that we have just created, right? You can see in total, we actually got 3 model sequences. One in the pre-states, one in the post-states, one hypothetical version from the pre-state, because we want to know if we just do this little addition to the pre-state, that should be equivalent to the one in the post-states, right? So now we're comparing the blue one over here with this particular pink one. Are they equivalent? Well, they are, because you can see Alan, Mark, Tom, Jim, and also Jim. So this is actually satisfied. So that's how we actually evaluate this particular contract for the push. Okay, and then you will see other contracts written in terms of the model. Okay, so you can see this contract will always stay the same, simply because from the client's point of view, the end of the sequence is always the top of the stack. It always remains the same, regardless of what the underlying implementation strategy is, either in the normal order or opposite order. It doesn't matter. Okay, the only thing we have to modify when we go from one strategy to another is about how you promote the implementation to the model. So that's the exercise you had to do. So let's now switch back to the slides to finish off this particular topic quickly. Okay, so now everything on the slides has been talked about, just mention a little bit more detail to some diagrams. So we talk about math models is like a written summary of what we just said about abstraction function using commands and also using queries for writing contract. Okay, that's something we talked about already. Okay, and then that's about how you implement the abstraction function. Actually, you will find the answer from the slides, but I would suggest do the exercise before you find the answer. Okay, so now this is just about how you can implement the abstraction function. And remember, let me say it again. This is the only place where you actually try to draw the relationship between the result and also the result, which is of sequence type, the model, and also the imp. This is the only place. Other than that, you're going to just use model to write the rest of the contract. For example, for strategy number 1, you can see this is the only place where we try to relate the array order with the sequence order. That's the only place. Other than that, you can see we only use model here. We use model here, and also we use model here. Similarly, for strategy number 2 and 3, I'll let you study the details. Okay, so now let's see this. Okay, so this diagram, let me just explain for one strategy here. The other ones will be the same. Okay, so conceptually, this is what we are doing. Okay, so now what we're doing is this. Think about, we try to have some implementation over here. So let's say for strategy number 1, implementations of type array, and then when we do the implementation for push, it's going to force into the array over here, and then we're going to get some new array. However, this detail about forcing into the array in a particular order should be hidden from the clients. The way we have stable contracts is by using the math model. and we have to define something called abstraction function. In that case, calling the abstraction function, which is model, right? In the pre-states, it's going to give us one sequence as we illustrated on the iPad, and then calling that in the post states is going to give you just another sequence. And now you want to compare how these sequences are related to each other, rather than comparing how these two arrays are related to each other. Because if you only compare the implementation, then you have to change from strategy to strategy, because you may not be comparing in the same order or maybe the opposite order. So now if you do the same single view, comparing just model sequences, it will always be the same from the client's point of view. We are making for the convenience of our clients, which we should do as a good design. Okay, so that will be the same diagram for strategy number 2 and also strategy number 3 as well. So you can see the diagrams in the slides. I'll leave that to you. Okay, and then I just want to point out finally to see how we can satisfy the 2 design principle in a moment. Okay, so that's about the, you can see also the written description over here, but you can see the contract will always be this, always, okay, between strategies. Okay, so now you will see for abstraction number 2, so that's just another abstraction function. So that's kind of like a solution to you, but I would suggest again, try to do that by yourself before you see the solution. Okay, so now the same, you can see what we changed was now the yellow part that's highlighted, right? So now we are writing all the contracts in terms of the model. Okay, and then we have this diagram here just for strategy number 2. Okay, and also you can see the same contract here. We didn't change the contract, even though we didn't change the contracts, even though we changed the implementation. Okay. Okay, similarly for strategy number 3, okay, it will be the same. You can also see how the implementation goes. Okay, well, that will be for your reference. And then you can see the contract also are written in terms of the model. Okay, you should really try to look at the slides and also together with the iPad illustration. I think they try to talk about different perspective. Slides give you complete details. iPad is supposed to give you intuition, so that will help you comprehend the materials. Okay, that's about number 3. Again, you can see the abstraction function will be different. However, the contract will be identical over here, just the same. Okay, so now we want to see why using this math model and abstraction function idea will actually let us satisfy single choice principle and also information hiding. Okay, so these are just the slides. You can read them through. I will expect you to read them. Okay, basically once we use them, we have the same single view from the clients. I'm going to illustrate you on the iPad, right? You can look at that, just a written summary of what I said when I demonstrated on the iPad. Okay, and also now let me just this slide I'll let you read it. I just want to show you on the iPad as a final remark. So this is now the final version we have. So now for strategy number 1 over here, for strategy number 1, you can see here, this is the public model over here. You can see the implementation is completely hidden. That's why it's exported to none. Okay, and then this is the only place specifying relation between the result and the imp. That's the only place you will see the imp. That's the only place. Okay, and then you can see now for all the public queries over here, make, push, and pop, it will simply just refer to model, model, and model here, right? It will just be that. So now think about why, first of all, why information hiding principle is actually satisfied. Let me just rephrase what the stat is trying to say to you. Information hiding principle is satisfied because number 1, the implementation over here is private, so client wouldn't know what the implementation type is. Number 2, from the contract, the client only see the model, which is of type sequence. So the client wouldn't know whether you're talking about array or linked list of either the ordinary or opposite order. So that's why information hiding is satisfied. So now what about single choice principle? Single choice principle is satisfied because, let's say, what if I want to change from strategy number 1 to strategy number 2? Let's say that's a change I want to make. Change from strategy number 1 to strategy number 2. In the previous version, we had to modify every contract that as I illustrated to you. But now, do we need to modify the contracts? The answer is no. We will leave just the same contract over here. So model, model, and model, just the same. So you can think about this is the same as this. This is the same as this. And this is the same as this. No change on the contract. The only place, the single place we have to modify will be over here. So if we change from strategy number 1 to strategy number 2, the only place you have to change will be this model over here. Internally, this will be the implementation of how you do the conversion. You have to change, and also the relationship between the result model and also the implementation. Okay, so this will be the post condition you have to change. So you can think about this is the single place you will have to change. To modify. So we are now satisfying both information hiding and the single choice principle. Please make sure you really understand why these two principles are now satisfied by the new version where we use math models and also abstraction function. It'll be very important for you to appreciate what we're doing here. So later on, whenever possible, you should really use a math model to write your contract rather than in terms of the linked list or arrays. Okay, so that's pretty much about the end of this particular lecture, which is 1 hour shorter than usual because we actually got 2 hours over in the previous 2 weeks. So we're trying to compensate for your workload. But just to give you some conclusion from this week's lecture, just to give you a little bit of guidance on how you can study. So you want to really make sure you understand about how you can use the math models, particularly the sequence class. That's all you have to study for the math models for this week. Learn about the sequence model class. So beyond this lecture, learn about the sequence. You know how to find that in the iPhone Studio. Learn about the features. They might be covered in the quiz for this week. Okay, and then you want to make sure you digest the following ideas. Number 1, about information hiding principle. Number 2, about single choice principle. Number 3, for the very initial 3 strategies of implementations that we talk about, how you can write the contracts using a cross loop. Right, and how they actually violates the 2 design principles that we talk about. And you want to make sure with the help of the math models, both for abstraction function and also for writing contract using math model, why we can actually now satisfy the information hiding and single choice principle. Okay, so that's about what you should do for this week. Just make sure you also study for the sequence class in the math models. You don't really have to understand every detail, but at least if I put some question on the quiz, you will know which feature I'm referring to. And one more clarification, in the very beginning of this lecture here, let me just go there. I actually mentioned about there will be some self-guided study that you have to do about a review of the basic discrete math. We'll shift that to next week. So for this week, you don't have to worry about this self-guided study. We want you to digest these 2 points first of all, and then we will let you do the self-guided study next week.